1.15 Limits at infinity and horizontal asymptotes. If the denominator grows faster in a fraction, that means you have a small number on the top comparatively and a huge number on the bottom. And when that happens, the limit is going to be 0. Again, the bottom of the fraction grows quicker than the top as x goes to infinity or negative infinity. If the numerator and denominator grow equally fast, then you have a big number over a similar big number, and you have a limit of 1. If the numerator, the top of the fraction, grows faster than the denominator, then you have a big number over a smaller number, and then you have a limit of infinity, or in other words, DNE, or no horizontal asymptote. No horizontal asymptote means it just does not approach like a specific number that's finite. So here are some functions for us we need to know which functions grow quicker than the others. You can see we have a bunch of functions here. X squared, x cubed, x to the 10, x is the base in all of those. You have 2 to the x, e to the x, 4 to the x. And if you forgot, e is just approximately 2.71. It's Euler's number, it's a constant anytime you see e. So you see when x is equals 1, we have all this, right? X is equal to 10. These functions all increase at different speeds. But you see as x gets to 1,000, right? We don't care about these low x values. We care about as x values go to infinity, infinity. You can see this one, 4 to the x, grows the quickest out of all of these. Grows the quickest. You can kind of see the x's in the exponent, and 4 is the largest number out of all these three functions that have an x in the exponent. The second quickest is e to the x, because that's 2.71 to the x power. Third fastest is 2 to the x, and then x to the 10, and then x to the third, x squared, and then ln of x grows the slowest out of all of these here. Again, you'll be using these to help you solve these limits. We're going to get to some practice now. So find the horizontal asymptotes of each function. So right here, you can see the largest term on the top is the x squared, and the bottom is just a 3x. If you go to the top here, you see x squared, well, x squared increases quicker than just an x, right? So that's the numerator growing faster than the denominator. So we have a big number over a not so big number. We can say, well, no horizontal asymptote because it's technically infinity, but we do not count that as a horizontal asymptote. No HA. For question 5, again, you just look at the thing that increases the quickest. In this case, the highest variable here is an x. An x on the top and a 3x on the bottom. So you just take the coefficients of each of them. So it's 1x on the top, 3x on the bottom. It's just 1 over 3. Question 6, we have an x on the top, but an 3x squared on the bottom. The bottom is increasing, the denominator is increasing quicker than the numerator. Therefore, you have a not as big number over a super duper big number as x goes to infinity. Therefore, the horizontal asymptote is y is equal to 0. For question 7, this one looks a little more complicated. However, it's not too bad once you know the trick. So you see I have a 4x minus 3 squared, and if we expanded this all out, the first term would be 4x times 4x, which is 16x squared, and then plus whatever it is. We don't care about the rest because we only care about the term that increases the quickest, which is 16x squared. On the top, if you do the x times x, it's x squared, and the rest is unnecessary here. With this, you see there's an x squared on the top, 16x squared on the bottom. So the horizontal asymptote is just 1 over 16. Question 8 down here. So anytime you see a square root here of a squareds, you have to be careful with this. So the square root of 4x squared is going to be 2x. However, we have to break it up into 2 because you have to be careful with the positive negatives. As x goes to positive infinity, it's a 2x over 3x, which is just 2 over 3. Because if you recall, so we have a 2x on the top, 3x on the bottom, y is equal to 2/3. However, if x goes to negative infinity, y's, well, the top is still going to be a 2x, but the bottom is now going to be a negative 3x because x is negative. So you're going to have a negative 2/3. Again, anytime you see the square roots, you have to be careful. As x goes to infinity, let's write this here. Absolute value of, square root of 4x to the fourth is 2x squared. So 2x squared over 3x squared, y is equal to 2/3. And then as x goes to negative infinity, y is going to be equal to, well, 2x squared over, 2x squared over 3x squared, but negative infinity squared is just positive infinity squared, so this is still 2/3. Again, in question 8, this is just an x by itself. However, in question 9, the x is squared, so even as x is approaching negative infinity, a negative number squared is still positive. So, all right, getting to calculating some limit questions. Number 10, limit as x approaches infinity of negative 4e to the 1 over x. So, if you think about it this way, negative 4e, if you plug in infinity, 1 over infinity, that's pretty much a value of 0. Like 1 over a large number is just 0. So you can rewrite the 1 over infinity as a 0, and then e to the 0 is just 1. So negative 4 times 1 is just equal to negative 4, right there. So question 11, the first thing you should want to do is rewrite this. Limit as x approaches infinity. 5 times e to the negative x is 1 over e to the x. So e to the negative x is equal to 1 over e to the x. That's just your negative exponent rules. And you just have the 5 on top there still. Now, if you think about plugging in the infinity to the x, that's 5 over a really, really, really large number. So our answer is just 0. Good. This is an e right here, e to the infinity. Next page. So here are some trig limits. One thing for this one, sine x over x. Well, if you recall, sine, your trig functions is always going between -1 and +1, but then you have the x on the bottom. So you're going to have this closer and closer to 0. That's going to be the horizontal asymptote. Y is equal to 0. This one right here, if you think about plugging in the infinity to x, the 1 over infinity is the same as a 0. So we can rewrite the 1 over infinity as a 0 right here. That's -3 multiplied by 1, which is just -3. 14. If you know the sine function looks something like this. It just oscillates, if it's just by itself, right? So this, there's no limit. It does not exist because it is oscillating. Question 15. Same thing. Because you're multiplying here, 5x times cosine x, you're just going to keep oscillating. But in this case, you're going to look like this, growing larger and larger, like large waves. D and E, we can say oscillating, but it just looks like that. It's just going larger and larger because you're multiplying here. All right, that's it. You can start the practice or ask your teacher for any questions.